What is up, amigos? Today we're talking about antenna helical strakes. So in terms of a car, there are quite a few different antennas. And one which is very common is if you have like the roof of the car, then you just have this big stick just sticking up. And this is very traditional and still quite common. Now, helical strakes, if we zoom in to this antenna, they look like this. So what this is let's say we have this zoomed in picture of this antenna. And usually there's a smooth surface, but then we have like this wire curling around it all the way. So what is this and why do we use it? Well, this is actually a very common flow control device for cylinders in general. So if you go into the industrial part of your city or town and look at the chimneys there, you'll often see something very similar to this. And traditionally what they're used for is to suppress what's called VIV. So if we have a cylinder without this on here, and the flow comes along, the flow will start to shed in a von Karman Street fashion. And if you don't know what this is or the straw number is, check out this video here, which is actually a Aero fundamentals video we've done. And what this does is it creates this side force on this object. So if I had this pen here and a flow going over it, it will then create these vortices, one on each side, and it will start to wiggle around and start to potentially resonate and then break. Now, in terms of an antenna on a car, we don't actually use these helical strakes for this purpose. However, this phenomenon does occur if we don't have them. But the reason why we use these helical strakes is to suppress noise. So if you have this antenna without this wire on there, this helical strake that wraps around it, you will start to get these vortices, and these shed at a very specific frequency. And that frequency is tonal. And that means that we can actually hear this noise, and the faster you go, the louder this noise becomes. So by putting this wire around here, we suppress this VIV, these vortices being shed in this frequency, by breaking up where the flow will separate along this surface. So instead of breaking up like literally just this line, and it always breaks at that point, some flow will separate here based on the wire cutting the flow and like pushing it out. Some will separate here, some will separate more upstream, downstream, and the tonal starts to become more broadband. And that means that the noise in general starts to become less annoying. And yes, you will reduce the drag that this produces, but because it's an antenna, it's very small. You might cut the drag in half, perhaps, by reducing this vortice-induced vibrations and vortices in general. But because the antenna is so small, it's like not even a count of a car, so on a car. So it's in terms of the aerodynamics that it has on the car, its effects is minimal. But in terms of the aeroacoustics, it's very large because the antenna here, without this helical strake, produces a lot of noise, and with it we can cut the VIV down and these vortices down by like 99% and get rid of all that noise. So that is what this helical strake is on this antenna and why we have them. So that is in this video. If you liked it, make sure to click the subscribe button and like button, and I'll see you in the video. Peace, amigos.